right, now, in this episode 2 of the notes for 10.2, basically we're going to look at how do we construct a confidence interval. Now, a confidence interval, again, is whether you're setting it up for a population to estimate a population proportion or a population mean, is basically very similar. So again, what it is, it's a range of values that's used to estimate some population parameter like a population proportion. All right? It is based on your point estimate, in other words, your sample, in this case your sample proportion, just like it was last part for your sample mean, and then you add or subtract that a margin of error. And again, the margin of error is some critical value times the standard error. The standard error, again, is just the standard deviation of the sampling distribution of all sample proportions, okay? And that's the exact same, matter of fact, I just basically took this slide off of from our last target. Now, what that critical value is, how we find it in that standard error, that's going to differ a little bit, but it shouldn't be too difficult if you understood the last target, okay? First of all, the critical value, first, when we did population or sample means, using that to estimate a population mean, we used a t-distribution. Why? Because sometimes for very small estimates, that t-distribution changes shape. Well, when we find critical values for population parameters or population proportions, we're going to use the normal z-distribution. We're not going to use a t, we're going to use a z. It's basically that same normal distribution you were using a couple last standard. And I'll go through this with you and show you how to find it if you don't memorize these, but the critical value for a normal sampling distribution, denoted by this time z of alpha divided by 2, can be found with a table, which we're not going to use, but we will use technology. Now we use a z because we are finding the z-score for a certain area under the standard normal curve, okay? And these are the most three, just like they were last target, they are the three most common levels of confidence, 90%, 95%, and 99%. And the nice thing about this is usually our samples are so large that these critical values are not going to change for a level of confidence. So for a 90% level of confidence, your critical value is going to be 1.645. Okay, and you can just, if you can memorize that, it'd be perfect. If not, I'll show you how you can find it. 95% is 1.96, and then for 99% it's 2.576. So again, unlike a t-distribution where you have very small sample sizes and those critical values can change for those level of confidence, basically these are the three we're going to use. Now, if you don't memorize those, I'll show you how you can get these, and all you have to do is go to your ArtStat app, okay? And we're not using a t, we're going to use a z. So we're going to go to a normal distribution, and we're going to go to find percentile or quantile, and don't even mess with any of this stuff because we're on a standard normal distribution which says a mean of 0, standard deviation 1. For confidence intervals, you're always going to use a two-tailed, and then there's your central probability. So for a 95% level of confidence, your critical values are 1.96, just what it said on the in that table. If you want to go for a 90%, it's 1.645, which was, again, notice there's nothing here about sample size, okay? It's 1.645. If you want to go to 99%, it's 2.576. And then if you wanted something other than those three, like let's say a 98%, you could easily get those critical values from here. But for when you're using a z table, it's best if you just memorize these and you don't have to worry about them, okay? All right, so that's how you get the critical value. And it's just right here, it's just what we were on using our ArtStat. You can also use the StatMedic applet if you need to. Now the standard error, how do we calculate that? Well, again, what the standard error is, it's the standard deviation of a sampling distribution of a proportion. In other words, ladies and gentlemen, it's basically just calculating the spread for a sampling distribution of sample proportions. Now, I can go into a lot about how they come up with these formulas, but again, that's not the gist of this course, or just this is an application course. I'll give you the formulas and how you're going to use them. Now, if we happen to know the standard error of a population, of the entire population of sampling distributions for sample proportions is found by taking, ladies and gentlemen, the population proportion times 1 minus the population proportion divided by the sample size, and you take the square root of that, okay? Now, obviously, we're estimating the population proportion. We don't know what it is. So, ladies and gentlemen, if we don't know what it is, then what are we going to use to estimate? Remember, the best estimator of the population proportion is the sample proportion. So we're actually going to use this formula for our standard error. Notice it's the same formula as above, but we're estimating the population proportion with p hat, the sample proportion. So we're not going to use this because we don't know what rho is. We are going to estimate it by using the square root of p hat times 1 minus p hat all over the sample size. So again, this right here, ladies and gentlemen, is going to be our standard error. Right here. So now we know the critical values. We now know how to compute the standard error. By the way, that standard error comes back from target 8.3 when we talked about binomial probabilities and we talked about the standard deviation and how to find that and so forth. So again, these formulas basically come from target 8.3. So that's going to end this part of the notes, and we'll continue onward with episode 3.